This video is an introduction to Mechanism Explorer. Mechanism Explorer is a set of questions that you will find in Wiley Plus, and they allow you as a student to practice your mechanisms. And as an instructor or a faculty member, they allow you to assign these graded mechanisms that the computer grades, but it allows the students to get a very similar experience to what they would on a written homework. So if you have a question from Mechanism Explorer, you're going to get a page that looks like this. So you'll click on the first question. There's the Mechanism Explorer. You'll click on that button and it'll open up another page that will be where you solve the mechanism problem. So the problem itself is down here. So here we have this bromide. So we have a 3-bromo-3-methyl pentane reacting with this ethyl thiol, and we get a mixture of products. So this is showing you the products that you have to create. The key feature of Mechanism Explorer is the artificial intelligence. So any reaction in reaction drills can automatically be converted into a mechanism through this artificial intelligence. And when you're working the problem, it will be able to predict what your products will be based on your arrows. So as a student, what you need to do is come in. The first thing you need to do, and the only button you'll ever really click in this palette, is the electron flow arrows. And you want to make sure you click the double one. Now, if you know the mechanism, because you've been studying, you will know that the first step in here is the loss of the leaving group. So you highlight the leaving group bond, and then you draw an arrow from the leaving group bond to the leaving group, indicating it's going to be lost. Whenever you're done, you click the apply mechanism, and that will give you the product of that first step. There is a hint in the solution button. The solution button will be disabled on certain problems, and if you click the solution button, you basically sacrifice your attempt at that question. So we've lost the leaving group and we formed the carbocation. Now let's say we make a mistake. So we have to take this sulfur and attack this carbocation. That's the correct step. So when you're starting at an element with lone pairs, you don't start at the element itself. See, we don't want to grab that element. And once again, I made a mistake there, which you need to remember is you need to grab the double-headed arrow. Every time you come back, you have to grab the double-headed arrow. You don't start at the element because you can't draw a bond. So if I'm at the, put my cursor on the S, I can't draw that electron flow arrow. What you need to do is grab one of the lone pairs. So you can click the atom so you can make those lone pairs very big so you can grab them. Or if you just highlight the lone pair with your arrow, you'll grab it. Now I'm going to send it to the wrong carbon. I'm not going to send it to the carbocation carbon, which is this one right here. I'm going to send it here. When you extend out the arrow, initially there's a dotted line showing that it's this sulfur connecting to that carbon with the arrow. If you highlight the arrow to get green and then click it, it'll extend all the way. The system will accept either one, but as a student, when you're writing this on a test or written homework, your faculty member is your professor is going to want you to go the entire distance there. So let me just undo that again. So there we have, when you do your first arrow and you highlight the electrons and carry it out, initially it's going to show the dotted line showing the extent of the arrow. Then if you click the arrow, it'll go there. Now we've drawn the wrong thing. So if we click apply mechanism, what's going to happen is it's going to show us the product of that mechanism. This is the great detailed feedback you get from doing this. So it doesn't just say incorrect, it shows you what you did and what would result. You're violating the octet rule, you're attacking a carbon that is not electron deficient. Every step you do is listed here. So if you do 50 steps trying to figure out the mechanism, they'll all be listed here so you can go back and look at them. At the very bottom are only listed the 4 correct steps. So the first step you've got correct, the second step you haven't got correct yet, so it's not unlocked. When you get it correct, it'll be unlocked and they'll continue on through. So as you go through, let's say you've done 10 steps and you've gotten most of them wrong, and you're like, okay, what are the correct steps? You can come look at the bottom and say, okay, that's the first step, that's the second step, okay, I'm on the third step, what do I do? So let's go back up to the problem. In this particular problem, just remember, this is an SN1 reaction, and lots of times there's a competing E2, so you really have two products. So we're going to get the first product correct this time. We're going to have it go to the carbocation. We'll extend out and then apply mechanism. That'll be the carbocation product that we want in the structure. So we're told correct. We've correctly added that in. So remember, we're trying to get this and this, the substitution and the elimination. So now we have an extra hydrogen. So this is just a generic conjugate base, generic base, and it's going to go grab that hydrogen. We need to extend that out, or you don't need to, but you should extend it out so that you get used to writing the full arrow, because that's what you have to write on your written homework. Then we have to have the hydrogen-sulfur bond breaking, so this is just straight acid-base reaction. Base attacks the proton electronegative atom bond, in this case HS, breaks. We'll apply the mechanism. That will get us now our final SN1 product. Initially the sulfur attacked, but it had one extra proton. Now we've removed it, so we've gotten this product. If we look at the bottom, we can see we've got this step, we've got the sulfur attack to form the protonated sulfur, we have the deprotonation of that sulfur to give us the final product. What we're missing is this step, which is the formation of the elimination product. Remember, this reaction is a mixture of elimination and substitution. To show you how it wants you to do the elimination now, it has pulled this hydrogen out. Notice, if you notice before when we did the the sulfur attack on the carbocation, that proton was not pulled out. So it was telling you, do the substitution now. Now it's wanting you to do the elimination. So we come in, we get the electron, we go over to the hydrogen, we expand out that arrow. You have to expand out that arrow before you draw the next bond. So now the hydrogen forms a double bond. So the base pulls off the proton, and then the electrons from the proton-carbon bond are moved to form the double bond. This is typical E1 mechanism. I said E2 earlier, sorry, E1 mechanism. So we apply the mechanism. Since we formed the carbocation first, it's going to be an E1 or an SN1 mechanism. And we're told correct, and we get a code. You have a code that is randomly generated as soon as you click the problem. So when you click the problem, you have a code. When another student clicks the problem, they have a code. So as a faculty member, you don't have to worry about the codes being shared. We plug in that code, submit our answer, and we've solved the problem. So that's an introduction to Mechanism Explorer.